Hey folks, today we're going to talk a little bit about resistance. We're talking about electrical resistance, which is the restriction of current flow in a circuit. So we've got our multimeter today set up to meter resistance. The setting on the dial on your multimeter is going to be indicated by the Greek letter omega, which looks like a horseshoe, and that's going to meter resistance in ohms. So that is a unit of resistance and will allow you to determine the resistance of a circuit using the probes on your meter. So the first thing I'd like to show you is that every circuit has some resistance. So when you meter a circuit, even if you're just touching the probes together, even if you just clip these together, you're going to see a resistance shown on the meter. So this is something that a lot of guys don't understand and don't know about, but there is definitely resistance on every circuit. So you're going to want to be aware of that. So the other thing that you're going to want to do is be able to meter the resistance of an actual resistor, because there are certain applications where you're going to need resistors in installations. And the value of a resistor can be read off the resistor itself by reading the color bands. However, a more accurate reading will be obtained by actually connecting your probes to either side of the resistor. Resistors are non-directional, so you can install the resistor in your circuit either direction. You'll notice that if I clip the black probe to the right side and the red probe to the left side, my left side, meter reading is the same as if I were to do it the opposite way and connect the black and red in the other direction. You'll see the same reading. So not to be confused with a diode. So this is what a diode looks like. You'll see a gray stripe on one side. It is a black device with a cathode and an anode. This is directional. This is not a resistor. Diode. This is a resistor. So they come in lots of different shapes and sizes. You can get variable resistors or fixed resistors. So this is what a fixed resistor looks like. Couple other things I want to show you with resistance. If you wire your resistors, if you need to use multiple resistors and you wire them in series, which means you wire them end to end. So basically twist the two ends together and meter the resistance of that then series resistor, you will see an increased resistance because the current now has to flow through both resistors to get to the other end of the circuit. So you'll notice an increase in resistance. It's going to be a direct correlation, so you just add the two values together. So for example, if this is 100 and this is 100, you're now going to see 200. If you wire the resistors in parallel, so if you were to twist the ends together, and now meter the resistance of that, you're going to see the resistance decreases because now that current, those electrons have two paths to flow, in which case they will have an easier time of getting through the circuit. So if you think of resistance like water flows through a pipe, now these electrons have two pipes to flow through. Although they both are restricted, it allows more flow to the other side of the circuit. Whereas if you were to connect those two pipes end to end with the same restriction on both, it's going to restrict that water flow to the point where you're going to have less flow coming out the other side. So that's just some basics on resistance. Hopefully this helps. If you have any questions, we'll be happy to answer them.